We'll talk briefly about standard minimization, otherwise known as the dual problem. It does involve the simplex method, but it doesn't quite use it exactly. We won't talk about the mathematics here. So here's how the setup. This still deals with constraints that are inequalities. We have variables, variable 1, variable 2, variable 3, and so on. We have an objective function that's a function of one or more of the variables. So some of these question marks could be 0, some could be 1, some could be 2's. It's just a function of the variables. The constraints are all of this form. Number times variable plus number times variable plus number times variable. These numbers could be positive or negative. However, they all have to be of the form greater than or equal to a constant. And the constant itself must be positive. If it's not, then it's not a standard minimization problem, and it can't it's not guaranteed that it can be done. Why greater than or equal to? Well, let's say these are all your constraints here. Suppose it were less than or equal to. Well, that would constitute an area under this line and an area under this line, making this the feasible region. Okay, well, if you want to minimize an objective function in this feasible region, then why not just pick 0, 0? That will produce an output of 0, and that will minimize your objective function in a lot of cases. So greater than or equal to, usually we have to allocate at least certain amounts of resources in order to be able to even perform the problem. Let's take a look at an example. The idea here will just be to write our constraints, and then we'll use technology to help us solve. So we have two different cities from which trucks are being dispatched from, Phoenix and Casa Grande, to outlet stores in Gilbert and Mesa. The truck company is contracted to dispatch 30 trucks each month, and we want to know how many trucks should they send out from each location, and to which outlets should they send them. Well, we know that based on from where they're shipping from, they're either going to go from Phoenix to Gilbert, Phoenix to Mesa, Casa Grande to Gilbert, Casa Grande to Mesa. So let's let each of these, the number of trips from Phoenix to Gilbert, let's denote that with W. So W equals number trips from Phoenix to Gilbert. And all the other variables will be similar in nature. So we'll call this X, the number of trips from Casa Grande to Gilbert, Y, and from Casa Grande to Mesa, Z. The truck company determines that it will need to send at least 12 of the trucks to the Gilbert location. Well, if it sends at least 12 trucks to the Gilbert location, that means that there'll be at least 12 trips there. Excuse me, at least 12 trips there total. So to go to the Gilbert location, you can either come from Phoenix or come from Casa Grande. So we'll have W plus Y has to be greater than or equal to 12. Similarly, 13 trucks to the Mesa location, so that means X plus Z must be at least 13. At least 15 trucks come from Phoenix, so that means W plus X is greater than or equal to 15, and at least 20 trucks can come from the Casa Grande warehouse. So at least 20 trucks means that Y plus Z must be greater than or equal to 20. The objective is they want to minimize, keyword, the number of miles placed on its trucks. By the way, all the constants are positive values. So the number of miles, well, we're going to have 22 for a one-way trip. So that means that the objective function, which we'll call O, will be 44W for a round trip, plus 40X, because each trip from Phoenix to Mesa will be 40 miles, plus 62Y plus 76Z. Now, using our simplex method, here's the website. Now might be the time to pause it. We enter in minimize equals and then our function subject to each of our constraints, which we have listed here. Once we click solve, we get our optimal solution. It tells us that we should do 0 trips from Phoenix to Gilbert. Didn't say we had to make any. We should make 15 trips from Phoenix to Mesa, 20 trips from Casa Grande to Gilbert, and 0 trips from Casa Grande to Mesa. Now this can be justified because of the distance. The overall number of miles traveled would be 1,840.